welcome back. Let's do question 1.3. Consider the product. This is the product. These are the factors, right? And then if you multiply the factors, you get the product. Each factor in the product is of the form 1 plus 1 over n, where n is greater than or equal to 2. Determine all values of n for which the product will be an integer value. Right, so these are the n's, these are the values of n. So we can start with when n is equal to 2. When n is equal to 2, what we have? We just have this 1 plus 1 over 2. And then what is this? This is like 1 is like 2 over 2 here. It's going to be 2 over 2 plus 1 over 2 like this. And then what do we get? We get 3 over 2. Right? So when n is equal to 2, we don't have an integer. And then what if n is equal to 3? When n is equal to 3, we're going to have 1 plus 1 over 2, then times 1 plus 1 over 3 like this. That's when n is equal to 3. This 1 plus 1 over 2 just gave us 3 over 2, isn't it? This one. Right? And then what is 1 plus 1 over 3 like this? This will be just like 3 over 3. 1 will be 3 over 3 plus 1 over 3 like this, meaning that we have 3 over 2. I'm just taking this bracket, and then times 4 over 3 from this bracket. And then let's multiply these two. What we get? 3 divided by 3 is 1. Remember, you can cancel across multiplication. And then 2 into 2, 1, 2 into 4, 2. So it means here we have 2. All right. So it means when n is equal to 3, the product is an integer. Right, let's check. We want to see a trend here. When n is equal to 4, we're going to have 1 plus 1 over 2, 1 plus 1 over 3, and 1 plus 1 over 4 like this. That's when n is equal to 4 is equal to, and then this combination has given us 2, isn't it? This combination has given us 2, so it means this whole thing here is giving us a 2. So we're going to say 2, then times, and then this bracket 1 here is going to be like 4 over 4, then plus 1 over 4 like this, and then becomes 2 times 4 over 4 plus 1 over 4 is like 5 over 4. We can cancel across multiplication. 2 is like 2 over 1. So we can say 2 into 2, 1, 2 into 4, 2. So this one will give us 5 over 2. It's not an integer. Okay, we have an integer here. Right? So when n is equal to 2, the product is not an integer. When n is equal to 4, the product is not an integer. But when n is equal to 3, the product is an integer. Let's check the last one. So when n is equal to 5, we're going to have 1 plus 1 over 2, then 1 plus 1 over 3, 1 plus 1 over 4, then 1 plus 1 over 5. And then this part, we have done it in this step here. So it means these three brackets will give us 5 over 2. So it means we have 5 over 2. Okay, they gave us 5 over 2 there. And then this bracket, 1 will be 5 over 5 plus 1 over 5, meaning that we have 5 over 2 and then times 6 over 5 like this. Right, and then 5 divided by 5 is 1, 2 into 2, 1, 2 into 6, 3. So this is giving us 3. Let's check here. If you check, if n is an odd number, then the product becomes an integer. Do you see that? And then if n is an even number, the product is not an integer. So it says, determine all values of n for which the product will be an integer value. So we can say the product will be an integer value for all odd values of n from 3, meaning that n should be 3, 5, 7, 9, 11. It goes on like that. So it means n should be an odd number, but from 3 and then going upwards.